Have you ever wondered how a tiny wooden stick dipped in chemicals can instantly turn into a spark that lights candles, ignites campfires, and changes everything from household chores to survival strategies? Matches might seem like simple everyday objects, but behind each one lies a fascinating history, a delicate production line, and a world of surprising controversies. Today, we're delving into the remarkable world of matchmaking. The intricate processes that transform raw materials into a tool so commonplace we barely think about it. From old rumors about dangerous chemicals to the hidden stories of worker health and safety, the journey of a single match is a lot more eventful than you might expect. Matches are often taken for granted, but they have a storied past that goes back centuries. Early attempts at creating a portable fire starter involved dangerously high concentrations of white phosphorus, which made the product shockingly flammable and sometimes toxic. One of the most unsettling chapters in match history emerged during the 19th century, when factory workers, often women and children, suffered from phossy jaw, a horrific condition brought on by prolonged exposure to white phosphorus fumes. Historians say these laborers were paid meager wages, forced to stand long hours in poorly ventilated rooms with little to no protective gear. Over time, accusations surfaced that the companies involved exploited their workforce and refused to acknowledge the risks of dealing with such volatile materials. Some critics allege that corporate owners prioritized profit over worker welfare, leading to a wave of public outrage and eventually stricter regulations. But that wasn't the whole story. After fervent pressure from social reformers and medical experts, manufacturers had to rethink their methods, seeking safer chemical alternatives and better working conditions. By the early 1900s, safer strike anywhere and safety matches gained traction, typically made with red phosphorus instead of the hazardous white version. The shift from white to red phosphorus helped curb many of the worst health issues, and it opened the door to widespread acceptance of this ingenious invention. From there, matchmaking advanced in leaps and bounds, with factories adopting new technologies to crank out millions of matches each day, all while reducing harmful side effects for both employees and consumers. Modern matchmaking is now a carefully choreographed dance between natural resources, chemical science, and high-speed machinery, an impressive transformation from those risky origins. But how does today's factory turn out these slender splinters of wood with such precise explosive potential? It all starts with one key resource: timber. The wood used for most matchsticks tends to come from fast-growing, renewable trees, like aspen or poplar, chosen for their straight grain and minimal knots. In some countries, companies are even required to follow sustainable forestry practices, ensuring that for every tree they cut, new saplings go into the ground. Factories typically receive enormous logs on conveyor belts or forklifts, each measured for moisture content and overall quality. Specialized saws strip the bark, slicing the logs into sheets just a few millimeters thick. These sheets then move on to a cutting station, where they're shredded into matchstick-sized slivers, often at dizzying speeds. A single modern machine can slice and dice enough timber to produce thousands of matches per minute. Once cut, the matchsticks go through a sorting process. Operators or automated sensors look for defects, sticks that are too thick, too thin, or warped. Any misfits are funneled out. Matches may seem tiny and inexpensive, but quality control is crucial. A match with weak wood or inconsistent thickness might snap when you strike it or fail to ignite properly. If you've ever used a flimsy match that breaks in half while you're lighting it, you know how frustrating that can be. Factories want each stick to be strong enough to hold up under friction, yet still delicate enough to ignite swiftly. This balance in thickness, density, and dryness isn't arbitrary. It's a result of carefully managed kiln drying or air drying that standardizes each stick's moisture level. Too wet, and the match head could sputter. Too dry, and you get an uneven burn that might compromise safety. But that wasn't the whole story. Even after these sticks pass inspection, their journey has barely begun. Next comes an essential chemical bath that forms the basis for the flammable head. The production line may have huge vats containing a blend of ingredients: potassium chlorate or potassium nitrate as the oxidizing agent, sulfur or other combustibles for fuel, binders to hold everything together, and colorants that give each head its trademark hue. In safety matches, the red phosphorus is kept on a separate striking surface rather than in the match head itself to lower the risk of accidental ignition. Instead, the head usually contains antimony sulfide or other stable chemicals that ignite only when they come into contact with red phosphorus on the strike strip. This design, invented in the 1800s, was a major leap forward in reducing random fires and the risk of storing large quantities of matches in one place. Factories employ elaborate dipping machines to coat each stick in multiple layers. First, there's often a primer layer that ensures better adhesion of the main chemicals. The match heads are dipped precisely so that only the tip and part of the wood are submerged, forming a consistent shape. Workers monitor the viscosity of the chemical mixture, adjusting it if it becomes too thick or too thin. They also keep an eye on temperature. Too hot, and certain chemicals degrade. Too cold, and they won't mix properly. After each dip, the matches need a precise amount of time to dry. Some match heads may require more than one dip to build the exact thickness or color, especially for novelty matches that come in unusual hues or produce certain burn effects. Ventilation systems siphon away potentially harmful fumes, and staff are typically equipped with protective gear, reflecting the lessons learned from the tragedies of past centuries. But the chemical dip is only part of the puzzle. Safety matches, the kind most of us see in cardboard boxes with a striking strip on the side, rely heavily on that friction surface. Factories produce these friction strips in long sheets or on rolls. They coat cardstock or other sturdy material with an abrasive mixture containing red phosphorus, powdered glass, and binding agents. The glass adds grit, helping the match head ignite on contact, while the red phosphorus replaces the dangerously volatile white phosphorus. When you scrape a safety match head across this strip, the friction, combined with the chemical reaction, sparks a small flame. Early on, manufacturers sometimes struggled with inconsistent friction strips, leading to matches that wouldn't reliably light. That spurred research into perfecting the ratio between abrasive and chemical components. Today, factories produce friction strips to strict standards, ensuring a stable ignition nearly every time. But that wasn't the whole story. As the next wave of technology arrived, some brands started adding water-resistant or wind-resistant features, layering more sophisticated chemical blends onto both the match head and the friction strip. These specialized survival matches can stay lit even in bad weather conditions or after being submerged in water. They're popular with campers, hikers, and emergency preparedness enthusiasts who rely on these sturdier matches when lighters might fail. Although not all factories handle such specialized products, demand for them has grown, fueling additional R&D and forging partnerships with outdoor retailers. Meanwhile, the standard matches that end up in the everyday home or restaurant go through high-speed drying tunnels after the chemical dips. Long racks carry thousands of matches at a time, passing through carefully controlled temperatures. At this stage, airflow is critical. If the match heads dry unevenly, it can lead to lumps or cracks in the chemical coating, potentially causing dud matches or unsteady flames. Automated systems track everything from temperature to humidity, adjusting fans and heaters in real time. It's an elaborate dance that ensures each head cures at the same speed, preserving uniformity. A single glitch could ruin an entire batch, not only wasting resources, but also threatening the matchmaker's reputation for reliability. After drying, the matches move on to cutting-edge inspection systems that use lasers or optical sensors to detect flaws. Even the slightest deviation in match head shape or size can be spotted. This is where advanced factories really shine, as the entire process has become increasingly automated. Robots help with most of the heavy lifting, from hauling logs to managing racks of freshly dipped matches, reducing the strain on human workers, and minimizing workplace accidents. People still oversee critical steps, verifying that the automation is running smoothly and stepping in if something unusual arises. The shift toward robotics reflects not just efficiency, but also a desire to keep workers safe from chemical exposure and mechanical hazards. But that wasn't the whole story. In some regions, smaller matchmaking firms still operate with more hands-on techniques, partly out of tradition and partly due to lack of capital for expensive machinery. These artisanal matchmakers often promote high-quality matches with handcrafted flair. Their approach might include specialized shapes, intricate packaging, or distinctive fragrances. Some produce novelty matches with extra-long sticks for fireplaces, or elaborate designs suitable for upscale restaurants and gift shops. Despite modernization, a niche for artisanal matches persists, suggesting that even in an age of convenience, there's still appreciation for craftsmanship. As soon as the matches have dried and cleared inspection, they head to the packaging line. You've likely seen matchboxes with iconic artwork or branding. Printing machines lay down vivid graphics on sheets of cardboard or small wooden boxes. Then automated assemblers fold, glue, and press these flat sheets into the familiar matchbook or matchbox shapes. Some lines can churn out thousands of boxes an hour, each precisely sized to hold a certain count of matches, like 20, 32, or 50. Workers occasionally do spot checks, making sure the folding is perfect and the friction strip lines up neatly on the side or fold-over flap. Meanwhile, the matches themselves travel on conveyors and are counted into each box using mechanical counters or optical sensors. If a box is supposed to have 50 matches, the system ensures it receives exactly 50. Variations are typically ejected for rechecking or repacking. After the boxes are filled, they're sealed, often wrapped or labeled with safety warnings. Depending on the brand and target market, you might see disclaimers about keeping matches away from children or storing them in a cool, dry place. Some countries require explicit warnings about the potential dangers of improper match usage. Others recommend disposing of used or partially burnt matches safely to avoid accidents. Factories adhere to local regulations that can vary significantly, especially when shipping matches internationally. Packaging lines sometimes bundle multiple small boxes into a larger cellophane wrap, which is then shipped in bulk to retail outlets, restaurants, or distribution centers. The end result is that distinctive box or book of matches you pick up from a store shelf, a bar counter, or a fancy wedding reception. Once those boxes roll off the line, a final wave of quality control steps in. Random samples get tested. Technicians might strike multiple matches to confirm they ignite reliably and burn at a stable rate. They also assess the friction strip's durability, ensuring it can handle repeated use. Matches that pass the tests are cleared for shipping. Any suspicious batch is flagged for a more detailed investigation. Through all these measures, modern match factories manage to keep error rates extremely low, a far cry from the chaotic days when matches could spontaneously light if jostled too forcefully during transit. But that wasn't the whole story. The match industry still wrestles with environmental and safety controversies. Critics raise questions about how the chemicals used in match heads might affect local waterways if factories dispose of waste improperly. Others point to potential hazards if large quantities of matches are stored under poor conditions. Manufacturers respond by emphasizing their compliance with strict regulations, their use of safer chemicals, and improved waste treatment systems. Many tout their shift towards sustainable forestry, insisting that for every tree cut down, new seedlings are planted to maintain ecological balance. There's also an ongoing debate about the role of child labor and low-wage workers in smaller factories around the world. Investigations occasionally surface, alleging unethical conditions in places lacking robust labor laws. Responsible factories stress audits, transparency, and certifications to distance themselves from such practices. Despite these issues, the humble match remains a staple, outlasting the rise of disposable lighters and even the shift to electronic ignition in stoves and grills. Some might argue that lighters are more convenient, but matches hold a timeless charm. They're cheap, biodegradable, mostly just wood and a bit of chemical coating, and they create an instant flame with that satisfying crackle. There's also a sense of nostalgia attached to them, whether it's the memory of lighting birthday candles or the comfort of having a small box in your survival kit. Modern consumers can also choose from creative match designs, color tip matches that match your kitchen decor, extra long matches for barbecue grills, or matches printed with personal messages for weddings and events. Even big corporations and tourist destinations still use branded matchbooks as a form of promotional merchandise, a marketing relic that endures despite the digital age. While some younger audiences may have never even used a match, the object persists, bridging old-school practicality with modern-day sensibilities. It's a testament to how an invention from centuries past can still stay relevant in a rapidly evolving world. But that's not the entire tale. If we look deeper into the match industry, we see a blend of nostalgia, science, and an ongoing commitment to safety and ethics. Manufacturers have come a long way from the horrifying days of phossy jaw and borderline slave labor. They've refined the production process into something both efficient and surprisingly beautiful. Watching logs transform into slender wooden sticks, then get dipped into chemistry that's as finely tuned as any pharmaceutical formula, can be mesmerizing. The high-tech automation stands side by side with old traditions, from the timeless cardboard box design to the carefully orchestrated friction strip. It's a dance of precision, a reflection of centuries of trial and error. What does the future hold for matches? Some insiders claim that as long as people need reliable, easily stored flame, matches will remain. Others speculate that lighters, electric sparks, and other technologies might push matches into a quaint corner of history. Yet matches are still irreplaceable in situations where electronic devices fail or where carrying a pocket lighter isn't practical. They also have strong symbolic power. In ceremonies, in rituals, in that iconic lighting of a candle that can turn a dark room warm and welcoming. Matches, in many ways, represent human ingenuity, the harnessing of fire in a controlled, handheld form that transformed our daily lives. So the next time you flick open a matchbox and strike that slender stick against the friction strip, take a moment to imagine the incredible journey that little piece of wood has taken. Recall how the industry wrestled with controversies, overcame dangerous working conditions, and eventually mastered the art of safe ignition. Think about the meticulous processes: cutting, drying, dipping, coating, packaging, that all work in perfect sync. Each match has a lineage connecting it to ancient fire-starting techniques, modern chemistry labs, and everything in between. Whether you're lighting a cozy fireplace or a birthday candle, you're tapping into a legacy that's both scientific and deeply human. It's a small spark, but it carries a story that has shaped industries, spurred social reforms, and continues to keep the flame of innovation burning bright. Matches aren't just scraps of wood. They're part of an unbroken chain from the earliest days of fire taming to modern high-tech production lines. And in a world that often forgets about such mundane items, it's worth remembering the drama and triumph that go into making each and every one of them. Will the match endure for another century, or will new inventions finally eclipse it? That's anyone's guess. For now, this matchmaking process continues on, quietly fueling hearths, stoves, celebrations, and memories. An everyday marvel that has earned its place in the annals of invention. Maybe the next time you strike a match, you'll sense just a hint of that rich history and extraordinary effort sparking to life at your fingertips.